Chapter 7. It's easy. All right, we go. Composite functions. Let's recap. What do you remember about composite functions? Let's start off with Percy. What do you remember? So the definition. How do you know when you have a composite function? Let's start off with that.
Range of the function is subset of the original function.
Okay, let's say composite function f of g.
Yeah.
So range of what?
F is a subset of the domain of G.
It's the other way around. G and F, good. This is the property. Now remember, f of g, what does that mean? Oh, whoops. What does that mean? What's another way of thinking of f of g? What does it mean when I say f of g? What does that mean, Pius? You don't know. Jack? Can't remember. Josh? What's f of g mean? I love this. Say it again? Yeah, literally. When you say f of 1, it just means whatever f is sub 1 in. So when you say f of g, it just means whatever f is sub g of x in. Okay, so what it looks like is you're just saying sub g of x in. Which is why this definition is easy to understand. You don't have to memorize this. Remember, I'm not asking you to memorize, I'm asking you to understand what the definitions mean. See, f of g just means g of x is substituted into f of x. Why is it the range of g and not the range of f? Because g of x is the range. See, if I said g of x equals to x squared, you don't tell me that's the domain. See, x squared is not a domain. X squared is the y values. The domain is what I put into it. See, if I said g of 2, 2 is my domain, but g of 2 would end up being 4, because 2 squared is 4, so this is my range. That's why we say range of g has to be a subset, because you're substituting the range of g, that's the range of g. You're substituting it into f of g. That's why when you guys talked about 1 over root x before, and I said, why can't you have the negative values? Because technically, this is a 1 on x function, and all you did was you substituted a square root function in. See, the square root function, you just substituted in, you just made it 1 on root x. You substituted the x as a root of x. This is a composite function. So what are the range of this? This is from 0 to positive infinity. It has to fit the domain of this graph. But the graph of this has a domain that's all real values. That's why you have to restrict it. That's why this graph only looked like that. And you told me before, you said it can't have negative numbers and it can't be 0. What you were doing logically is what you're doing composite functions. The theory that you're doing logically is what you're doing here. We're just putting names to them. See, everything that you said to me when you were doing this before with me, and we said, what's x to the power of negative half? What you were doing, you said, can't have negative values? Well, how did you know? See, that logic that you're doing is this. This is what you're saying. You were just logically saying, well, you can't have negative values. That's why this wouldn't exist. Of course. I can't put a negative 1 there, because it might be the domain. The range of this won't exist. If the range of this doesn't exist, then it doesn't work. Okay, that's why you got to make sure that the range of this will fit the domain of that. See, the domain of this function is all real values. That's 1 on x function. That's what it looks like. But the range of a root x function, see, root of x, the range can only be between 0 to infinity, because this is the graph. The range is 0 to infinity. So the 0 to infinity has to fit into the domain of this, but there's a problem. That can't take negatives, but this can. So the only way for this to work, you restrict it. So you restrict it from 0 to infinity, then it works. See, 0 to infinity, 0 to infinity. The domain is 0 to infinity, the range is 0 to infinity. That's why it works. Okay, so what you're doing so far, logically, is what you're doing on paper theoretically. They're all both the same thing. That's why I'm asking you not to memorize that concept. And the examiners will play around with that. They'll do f of g, and then they'll do g of f. They're trying to get you to understand that is your range. Range is substituted into the domain of your function. Okay? So, now, going back, so now we know this is the only time that it works. If it doesn't work, if the range of g does not fit the domain of f, you don't have a function. Okay, it's like the one that Josh was asking me before. We had x to the power of half to the power of 7 versus x to the power of 7 to the power of half. What was the problem? The problem with this is you can't square a negative number. That can. X to the power of 7, you can have a negative value, but you can't square root a negative value. So this one doesn't exist. So when you type in your calculator, the only part that the calculator can do is sketch that. So they'll sketch a square root function and they to the power of 7 it. So this is what it will look like on your calculator, but they can't sketch this. So x to the power of 7 is like a cubic, and then try square root that. They can't square root any of these values here. They're all negatives. See, that's your range. That's a composite function. Range, your y values, sub into the domain of a square root function, there's a mismatch. One can have negatives, one can't. So everything that I talked about in the previous exercise is exactly what you're doing here. So whatever you can do logically, it's all theoretical here. Okay? So that's the first property. You got range of G needs to be a subset of domain of F. It's really just make sure that fits if you substitute it in. Okay? What is a composite function? It's a function within a function. So all the ones I just gave you, when I wrote x to the power of 7 on 2, you technically can have a square root function inside an x to the power of 7 function. The one I gave you was 1 on root x. That technically is the same thing saying 1 on root of x. You substituted root of x into a 1 on x function. So it's a function within a function is a composite function. Okay, technically an x squared is a composite function. Why? Because you can have f of x equal to x, and you can have g of x equal to x squared. If you substitute that in, then you get x squared. Okay, so just think about that. I'm just saying if that's x squared, f of g just means sub this into where x is, and you get x squared. That technically is a composite function. Okay, so a function within a function is a composite function.
Start meeting will be with Blackbird meeting tonight.
Oh, that's right, I got a meeting. Yes, I don't like it. I like my Mondays, 6 on, and then a meeting, and then Tuesdays I have a session 7 with you guys, and then I have a meeting afterwards. So I like my Wednesdays and Fridays. These are my good days. Anyways, here we go. What else do we know? I remember it just got recorded as well. Let's hope teachers never follow me on YouTube. All right, here we go. So we got this one property. There's one more property that you need to know. Composite functions. What else? One more. What's one more that I talked about? And they usually ask it in the exam. And students remember this because they memorize it. They don't remember the next one. There's one more. Was it in your sack? No, it used to be in the sacks. 2014, 2015 used to be in the sacks. What's one more? One more property that you need to know. He's bored as well. For a moment there, I thought it was one of you guys answering the question. You're like, oh. But that sounds like Mr. Patch. Yes, domain of f of g is
equal to domain of g of x.
good. No, g of x or g. Excellent. Same thing again. What I just showed you before. In order to have this property work, there's only two properties here, so I'm just going to recap you again. If this works, if the range of g fits the domain of f, that means good. You can have the function. So for example, I gave you 1 on root x. You just had to make sure that x is greater than and not equal to 0. So that means domain is R+. Okay, so if you restrict that and this works, so this is a composite function and it fits this property, great, that property works, then this follows. Okay, so this can't work unless this works. There goes 1, then 2. Now why is it that its domain of f of g is the same thing as domain of g? Is because, well, it's logical, because whatever you can put in g, okay, whatever g can take, obviously you're going to substitute it into f of g, so therefore it takes the same value. So if you think about it, if I draw a machine, this is g of x, and then you got f of x, true? what you're doing is, the number that you put into g of x is your domain. So I say x equals 1, that's your domain. You chuck into g of x, now it spits out g of 1. Then when you have g of 1, you put it into this machine, and then it spits out f of g of 1. Does that make sense? See what I'm doing there? So when you do the composite function, your domain started here. If this first step was satisfied that it is possible that you will get a number, that this does exist, it equals to something, okay? Then that means the domain, when it's the domain of g, it is also the domain of f of g. That's why it makes sense, logically, okay? Because you got to make sure that it goes into g of 1, and then whatever g of 1 is, it has to work for f of g, because if it doesn't, you have a problem. That's why we said over here, the problem with this type of question is if x was -1, it was a problem right here. If that's a problem here, then there's a problem here. That's why it couldn't exist. That's why I said we restrict the domain so that it works. We said that we have to make sure that x is anything greater than 0, then it should all work. See, if x was 0, if I said x was 0, then square root of 0 works. So square root of 0 works, so g of 0 works, but then you sub g of 0 in, you can't have 1 on 0. That's why it doesn't work. Okay, so that's why the domain, whatever you put in, if it works to begin with, it should be the domain for the f of g. Does that make sense? There's only the two properties. So composite functions, the range of g is a subset of domain of f if it's an f of g function. If it's the other way around, it's the other way around. Okay? Then your domain f of g is the same thing as your domain of g, based on this sort of concept. Once you understand that, they'll just get you to prove, I'll find out the domain of g, and we'll do some examples later. But here we go. Composite functions, these are your examples, we'll come back to that. Next one, inverse functions. So you got composite function, there's two properties there, and inverse functions are revised a couple of times already. Name me one thing. What do you know? What must you have, Josh? It has to be a one-to-one function. Why is that? Let's go Stephen Zhao. Why does it have to be a one-to-one function? Why do inverse functions have to be a one-to-one? Because otherwise it won't exist. Now, what do you mean doesn't exist, David? What does he mean? Something doesn't exist. What doesn't exist? The function doesn't exist. So when don't you have a function? Can I call it Frankie? When don't you have a function? When it's one to many or many to many. So what we're looking for is it has to have a unique y value. One to one is a unique y value. Many to one is also a unique y value. So when you do the inverse function, yes, it has to be a one-to-one function. The reason why is because it has to exist. Well, what exists? The function. Because the word function means unique y value. So, how do you test when you have a unique y value? You've done your vertical line test. Every time you cross once, it tells you have one y value, yeah? But the key part is, well, why? How do you know it's going to be a function or not a function? Because many to one, you told me that's a function. But why can't that have an inverse? Because a many to one is a a parabola, that's a many to one. Many x values for one y value. You can do that with a horizontal line test. Why doesn't this have an inverse function? Why is that? You still haven't answered that point. So you made good contributions. You did say this won't have an inverse function, okay? Because you said one to one, the only one that exists. And I said, well, what exists? You told me a function. You told me there are two types of functions. You told me there's one-to-one and a many-to-one. But why is it only one-to-one and not a many-to-one? What's the reasoning? David? Fantastic. So with the inverse, it's a transformation. It's a reflection along y equals x line. So remember, when you do the reflection along y equals x line, you swap the x and y values. If you swap the x and y values, the domain swaps and the range swaps. So that means a many-to-one function, if you swap it, what does it become? It now becomes a one-to-many. Now, is that a function? Is a one-to-many a function? No. That's what Frankie said before. One-to-many isn't a function because that's one x to many y's. What's an example of that? Square root function. 1x, so if x was 4, square root of 4 is positive 2 and negative 2. That's a problem. You can't have a square root function. You can have a square root relation. So this has a square root relation, doesn't have a square root function. Okay, so that's why a many to 1, even though it's a function, it doesn't have an inverse function. So why is 1 to 1 the only one? Because if you swap it, the x and y's, it's still a 1 to 1. That's why the inverse exists. Okay, so let's recap again. It's 1 to 1, otherwise it's called an inverse relation. I just gave you an example. So many to 1, if you swap it, it becomes a 1 to many. 1 to many is a relation, not a function. Yeah? I gave you an example here. Domain, don't worry about that. No, okay, forget about that. There's one more couple of properties. So it's 1-to-1 function. It needs to exist. You can do a vertical line test to test if it's a 1-to-1. I mean, it's a function or not. Otherwise, it has an inverse relation. We also know transformation, you swap the y and the x values. It's a reflection along the y equals x. And I said before, it swaps your domain of your function now becomes the range of your inverse, and the range of your function now becomes the domain of your inverse. Okay, so these are your properties here. 1-to-1, domain of f becomes a range, range of f becomes the domain. There's only the other two properties. Easy? And just in case another way of expressing this means reflect along y equals x line. So that's what you need to understand about inverse functions. Does that kind of rejog our memory? Yeah? All right. In this exercise, what you'll be doing, find the inverse function, find the domain, find the range, sketch the graph. Those are the kind of questions you'll be expecting. In the previous question, that's what I wanted. You guys, when you guys did this in term 1, when you guys did this in term 1, probably composite functions was where you can improve. Inverse, you did better. So let's focus on this one, composite functions. I want you to have a go with this one. Same thing again, the two properties you had, domain, range. I want you to just tell me which one exists, why, and how again. Restrict the domain so that it works, because these are the only type of questions you'll do for composite functions. Okay? So out of 7b, that's the only part that I want you to sort of revisit. In terms of inverse, you guys did really well last time, so study in your own time, you'll be fine. Constant functions. Give this a go. Give you, I reckon, 5 minutes, and we'll go through them. Same thing, I'll write down the properties again. If it's f of g, if you want to know if it exists, it only exists if range of g is a subset of the domain of f. If that is true, then you also know the second property, which is the domain of f of g is equal to the domain of g. That should allow you to answer all those questions then. Let's go, 5 minutes.
Wait, so we're doing 7a and b in this section.
Yeah.
What are we doing next session?
I'll try to squeeze in C and D.
And then e next. Because we have
It's only too hard. It's one of those literal equations, 7a.
Literal equation.
Yeah.
So just like copy paste.
Transpose. 2 integration.
Okay, then you did that as x squared. That is nowhere near. This is totally
How do you do this? Like, that's what we're given. And it's like express this in terms
Probably split up to start off with. That would be log of A3. Oh no.
Really? One of them does. Let me check the next one.
Wait, I have
They both don't exist.
Right.
Yeah. Like not like one. There's one includes the
All right, let's go through the answers. A. It's pretty easy. I normally use a table just so it's easier to see. And then I say find the range and domains. Now it's pretty easy. F of x, we know that the graph looks like this. Okay, it's all about visualizing. So I can already see that the domain is all real values except 0. And the range is all real values except 0 as well. Okay, so that's for f of x. G of x. What's my domain for g of x, Pius? Say it again. 3 to infinity, good. Because the graph looks like that. So starting from 3 to infinity. So it is, I'm just going to rub that out. So you have 3, domain is 3 to infinity, including. And then your range, we're just looking at the graph there, it is 0 to infinity. Okay. There you go. So I've done A. Second part, B. Now, if I want to check if f of g exists, so f of g, what must I check, Rex? Oh yeah, I wrote it up there already. Good work. So range of g has to be a subset of the domain of f, and we check. If you're doing this in the exam, make sure to write the value. Don't just write the definition. So you got to write down range of g. So in our case, range of g is 0 to infinity. And you check if it's a subset of the domain of f, which is r excluding 0. Okay, and we can already see, is that a subset or is it not? No, good, because this one has negative values, the other one doesn't. So it's plus, it's including the 0, whereas the other one doesn't. So this is not a subset. So that doesn't exist. Okay, so it doesn't exist. You can draw a number line if it helps you. If you couldn't picture it, like 0 to infinity looks like that for the range of G, and the other one was open circle. It's not a subset. Okay, subset means it's a part of, and in the first line that I drew has 0. This one doesn't. That's why it's not a subset. Okay, subset means you have to belong in it entirely. Okay, so the first line doesn't have it. That's why we know it doesn't exist. Next one, let's check G of F. So for G of F to exist, what is my property? Let's go with Gary. For G of F to exist, what do I have to check? Good. Is a subset of the domain of G of X. Okay, so we check that, and again, don't just write the definition, you have to write out the values. So range of F, R excluding 0, and we want that to be the subset of domain which is 3 to infinity, which we can already see a problem there. That's 3 to infinity. If you draw the number line out, you can already see that's not a subset. Okay, because it's not a subset. Both of them do not exist. Wait, what happened here? Oh, there we go. Both of them don't exist. So the next question, C, is what you are, like the bulk of composite functions, this is where it was sitting, where a lot of students were finding it difficult from chapter 1. The function that does exist, or both of them, they both don't exist, restrict the domain so it does. So the problem is your range doesn't fit right now. So your range of G of X, that's a problem. We don't want it to be 0 to infinity. We need it to be anything but 0 to infinity. We just don't want that 0. So the only way to do that is if you change a domain. So if you change what you're putting in, it changes what you get out. Okay, so the only thing I don't want is I don't want to have the 0. So the only way not to get the 0, change the domain here. For this one to exist, change domain of G to now not including 3 to infinity. So if you change it to not 3, then you won't have 0. If you won't have 0, you won't have 0 here. If you don't have 0 here, that's now a subset. Okay, so you can see how changing the domain affects the range, and the range is then fitting this. And that's the hard part where a lot of students find difficult. How do you get that? Okay, and sometimes visualizing helps, sometimes doing algebra. I always visualize. Draw the picture, look at what you need, and then fit it. Okay, so that's why I know don't include the 3. It means I don't include the 0. If I don't include the 0, this one works. Because the only problem was that it had a 0 and this one didn't. Okay, next one. G of F. How do you restrict the domain so that this works? So if you look at range of F, this is my graph, range of F. I want it to be from 3 to infinity. Okay, so I want this range to be 3 to infinity. So if I look at the graph, I'm going to use another color. 3 is somewhere here. So I want it from here to infinity. So I only want this part that I'm coloring in red. So that's what I want. I don't want anything else. The range needs to be 3 to infinity. If I can restrict that. So the question is, what should the domain be? That's what I want. I want this, whatever that x value is, up until 0. See, 0 to whatever that x value is. So how do you find that? You know the range you want 3. You want the range to be 3. So range of F, you want that to be 3. This is your function. If you change that equation, you write out, all right, well, I want it to equal to 3. Want an x. When will I have a 3? It's when x equals to 1/3. So that means when x is 1/3, I will have a 3. If I have it between 0 to 1/3, it will fit this domain, which is what I want. That was the hardest part that a lot of students have to work with. You see where I'm looking at? I'm looking at the range of F, and I look at the visual. I look at that and I say, what do I want? I want it from 3 to infinity. So I restrict that. I said 3 to infinity is up there, all the way up. So from here, I just needed to find the domain. Okay, so if you understand what you're looking for, it's easy to do. It's when you don't know what you're looking for, you have no idea what to do. Yeah? So I know I need to find that x, and I just found it. X has to be 1/3, so it's between 0 to 1/3. Now, because it says including 3, I can then include x equals 1/3. So changing my domain of, what is this now? Domain of f, whoops. Domain of f needs to be not including 0 all the way up until 1/3, and I can have 1/3. That's my x element. Does that make sense? I know that's a bit tricky there, but that's what I want you to practice. That's what chapter 7 is about, revisiting composite functions. Yeah? And finally, find the domain of f of g and g of f. Well, you technically found it already. Okay, whatever you have for this, it's the same as f of g and g of f for it to exist. Why is there 2 questions? Because this one's asking for to restrict it. A lot of students don't realize that that is the domain of f of g. They just know how to restrict it, but they don't know it's the domain of f of g or g of f. So it's the same question. A lot of students don't know that. Okay? So we finished up there. That's what I want. Please practice 7b now. We've got about 10 minutes. Practice 7b. I'll move to 7b for you. Let's go to 7b. And let's try 4. Let's do 4 or 5. You can start on 5 if you want, but we'll do 4. 4, and I'll pick out a question. Let's do 4. Oh, that's tricky. Let's do 4C. 4C should be alright. 4C. Sketch both of them, look at the domain, look at the range, and adjust it. Do 4C, composite functions. There's nothing in it.
Yeah.
Log base x. I would change the bases.
How do you change the bases?
Change your base, so change your base, I would say whatever this answer is equal to, let's call it A. Hypothetically. Then now I have A is equal to 81. And because this property is log base 9, I'm going to do log base 9. So that means now it's log base 9 of x to the power of A is equal to log base 9 81. I can put down the A, and then if I divide both sides, so actually I'll just write it out, the log base 9 of x times A is equal to log base 9 81. True. And if I rewrite this now, if I write A is equal to log base 9 of 81, or log base 9 of x. So if that's equal to A, what I initially said, log x of 81 is the same thing as writing log 9 of 81 as log 9 of x. And log 9 of x I know is u, and I know log 9 of 81 there's a formula for that, but I'm showing you the algebra to it. The formula, if I remember correctly, if it's log base A of m, and then it can be log base n of let's just look at my model. Is x 81, yes, that's right. So it would be log base n of m or log base n of m. That's a formula? But I don't memorize it, so I normally just do this to get there. But A could be any base number, it could be 3. Then n is whatever the new base that you want. So if you want it to be 9, it'll be 9, 9, and that A will be here, and n will be here. So it's a change of base formula. I use algebra.
Let's try 4C.